I have this handout link for you as well, so you can either print that out or just write out all on a blank sheet of paper either in your notebook. This section is all about inverse trig functions like sine inverse, tangent inverse, things that you learned last year, except the notation is a little bit different. So I'm going to review the pre-cal because my experience that students forget the pre-cal stuff here. So I'm going to try to review that a little bit. That's what the majority of this is going to be. And the calculus part is towards the end of the video. That's actually the quickest and easiest part. It's just some properties that we have to know and have memorized there. But what we're going to work with two different notations. So I got to get you exposed to both. AP test, colleges like to use different notations right there. So inverse sine of x is the same thing as arc sine of x. These are the arc trig functions, the inverse trig function is the same thing. So when I say sine inverse of 1/2, that's the angle whose sine is equal to 1/2, which is pi over 6. That's the same thing as arc sine of 1/2. That's just the angle whose sine is equal to 1/2, where your sine is equal to 1/2. That's on that unit circle where your y value is 1/2, and that's at the pi over 6 reference angle right there. So this stuff here, if you care, I just want to talk a little bit about why we need these answers in a very specific domain. These are inverse functions, right? For something to be a function, it has to pass a vertical line test. For something to have an inverse, it has to be 1-to-1, which means it has to pass the horizontal line test. Every single one of your original trig functions tremendously fails the horizontal line test, right? So what we had to do, what these like mathematicians did a long time ago, those math ninjas a long time ago, what they did is they just restricted the domain, all right? Think about all the word problems you do with inverse trig functions where you're finding that missing angle. Your calculator knows to find that missing angle right there. Those are so important that we have to have these things have inverses so we can find those missing angles and we can do the inverse trig functions. Now, so what we did for the sine graph and the tangent graph, we said that those domains were in between negative pi over 2 and positive pi over 2. That's one segment of that graph. That's one segment of that graph. Notice that bolded segment of that graph, it does pass the horizontal line test. So that's why we're sticking with those domains right there. And so in between negative pi over 2 and positive pi over 2, that's really sticking with either quadrant 1 or quadrant 4. So you're talking like pi over 6 and then negative pi over 6 to stay within that domain. So when I give you an answer here, and you're wondering, why can't I use 11 pi over 6? Because 11 pi over 6 is not in that domain. That's not what we're talking about, where those restrictions come from for that to have an inverse to even begin with this. So we got to use answers like negative pi over 6 instead of 11 pi over 6. And that's just when we see this notation is when we're worried about those domain issues right there. If you're solving a normal trig equation, then between 0 and 2 pi, then you're going to use the 11 pi over 6, the 7, 5 pi over 4, things of that nature there. The cosine one is the oddball because if you use the same domain for all three, the cosine graph in between negative pi over 2 and positive pi over 2 fails the horizontal line test. So we couldn't use that same domain. So in the cosine one, we just used in between 0 and pi, fails the horizontal, passes the horizontal line test, and that's in quadrants 1 and quadrant 2. Now this part down here, some of you may have learned the original trig functions by a chart method right there. Most of you, I'm pretty sure you use this technique over here with this first quadrant and the unit circle where you got your pi over 6, pi over 4, pi over 3, and you got your 0 here, you got your pi over 2 right there. So then remember your x is your cosine, your y is your sine value. Now, kind of what helps you, what I'm going to do is I call this my cloud, is I'm going to give you ways of how you can get all of these right if you're just using this. And the only time I need to use the cloud is if I see the inverse trig functions, the arc sine, the arc cosines, things of that nature. So what we're going to fill out together here, try to squeeze this in. Mine's not going to go in because I'm using these thicker markers there, so it probably won't all fit in the cloud. But if you have an arc sine or an arc tangent, those are friends. They have very, very similar domains except for the pi over 2 because you got the asymptotes at the tangent. But if you have an arc sine or arc tangent, what I'm talking about is this number right here. If that number is positive or if that number is negative, what our answer is going to be. So if that number is a positive answer, your answer will come from this quadrant 1 area, and your answer is always going to be whatever your reference angle is, which means your answer will always be the pi over 6, pi over 4, or pi over 3 every single time. If this number that we're doing the arc function of is a negative number, and it's an arc sine or an arc tangent, then your answer is going to come from quadrant 4. All right, that's the other part here. We're either in quadrant 1 or quadrant 4. And then your answer is always going to be the negative of that reference angle to put that in quadrant 4. So your answer is always going to be either a negative pi over 6, a negative pi over 4, or a negative pi over 3. And then the oddball guy is if you have an arc cosine. That domain is different. So if you have an arc cosine and that number is positive, no matter what, if your number is positive, you're coming from quadrant 1, your answer is going to be your reference angle. So it's going to be the same thing. I'm not going to write those again, but that's just your pi over 6, pi over 4, pi over 3. But if you're doing an arc cosine of a negative number, according to these domains over here, you got to give me a quadrant 2 angle. When you give me a quadrant 2 angle, technically, you're going to go pi minus the reference angle. And what I'm also going to write in here for you is it's going to be 1 less in the numerator. It's going to be 1 number less in the numerator to get that quadrant 2 angle there. So your answers are always going to be either a 5 pi over 6, a 3 pi over 4, or a 2 pi over 3. So those are your quadrant 2 angles corresponding to those specific reference angles. And notice how it's always 1 number less on the top, because if you go pi minus pi over 6, that's 6 pi over 6 minus 1 pi over 6, which gives you the 5 pi over 6, right? And so all I'm going to share with you here, you don't necessarily have to worry so much about all this. Just know that those are the reasons why our answers have to be in a particular domain. But when you're doing all these answers, if you just kind of know this cloud a little bit, you can get all these right. And so we're just going to go straight to the answers on here. So if I want the arc sine of radical 3 over 2, I want to know what angle is it where my sine is at radical 3 over 2. So my reference angle there, that's where that y value is radical 3 over 2. That's at the pi over 3 answer. So pi over 3 is my reference angle. And if this number is positive, I use the reference angle. So I simply use that pi over 3, and then we're done. And then so if I do arctangent of 1, that's the angle whose tangent is equal to 1. So that's where your sine and cosine are equal to each other. So you know the tangent is equal to 1 at pi over 4 is your reference angle. And when I do arc cosine of 1/2, that's the angle whose cosine is 1/2. And so again, at any time I have a positive number, I just use the reference angle. So the angle whose cosine is 1/2, that's where the x value is 1/2, and that's going to be at the pi over 3 reference angle. All right, now let's talk about how to do these negatives, right? If I have an arc sine or an arc tangent of a negative number, all I have to do is very simple, just stick a negative in front of that reference angle. So here the reference angle for where that sine is radical 3 over 2 is pi over 3. But if I have a negative right there, all I have to do is put a negative in front of it, and I get the negative pi over 3. Arctangent of 1 was pi over 4, so arctangent negative 1 is simply a negative pi over 4. And if you think about when you do the sine of a quadrant 4 angle, the sine of a quadrant 4 angle, or the tangent of a quadrant 4 angle from your all students take calculus, your sine and tangent are both negative in that fourth quadrant there. It's going to get you that negative answer. So when I do the arc sine of 1/2, we said up here that was pi over 6, but the arc sine of negative 1/2 is just going to be a negative pi over 6. So if you have an arc sine or arc tangent, those are simple. You just get to stick the negatives in front of those. But if you have an arc cosine, that's the one you can't just put the negative in front right there. So if you do an arc cosine of the positive 1/2, you get the positive pi over 3. But if you do the arc cosine of a negative 1/2, you can't just put negative pi over 3. You can't just, if that was easy, this video would have been like 2 seconds long. I'd just say, hey, when you put the negative there, just put a negative in front of it. That doesn't make any sense if you put negative pi over 3 here, because if you put negative pi over 3 there, you're telling me that the cosine of negative pi over 3 is negative 1/2, and that's just not true, because negative pi over 3 is in quadrant 4. So that means when you do the quadrant 4 angle, the cosine of a quadrant 4 angle from your all students take calculus is actually a positive 1/2, not the negative 1/2. That's why you got to give me a quadrant 2 angle, because your cosine is negative in that second quadrant there. So when you have the arc cosine of a negative number, you have to give me the quadrant 2 answer. So since your reference angle is pi over 3, you're going to give me 2 pi over 3 for that final answer. And then just a couple other examples there. If it's positive, use the reference angle. If it's negative, you got to use the quadrant 2 angle, which is going to be 5 pi over 6. All right, and then what we have to worry about is just problems that look like this. So when you see this, remember this is an angle, right? This is an angle whose sine is equal to 4/5. That's what that is. That's just some giant angle when you see that, where the sine is equivalent to 4/5. And so these are the problems where you're going to draw triangles on when you see these. So when you draw a triangle, it doesn't matter where you draw the triangle. So if I see arc sine or any arc function of a positive number, we're in quadrant 1, right? If I saw arc sine of or arc tangent of a negative number, then I'm going to draw that triangle in quadrant 4. If I see arc cosine of a negative number, I'm going to draw that triangle in quadrant 2. So if I have arc sine of 4/5, I'm going to draw a triangle in quadrant 1, and your reference angle is always this angle here next to the x-axis there. You're not using any angle out here in no man's land. You're always using that one next to the x-axis there. And then that's the angle whose sine is 4/5. Remember, just use SOHCAHTOA. That's opposite over hypotenuse. That's going to be 4. That's going to be 5. You can use your Pythagorean theorem. Now, once you have the triangle filled out, you can use any of the trig functions that I could ask you for any of the trig functions there. If I want to know what the tangent of this angle is, that's just going to be opposite over adjacent. Just use your SOHCAHTOA. So that's just going to be a positive 4/3. And since I'm in quadrant 1, I don't need to worry about the sign. If I'm in quadrant 4, then the tangent would have been negative in quadrant 4. You still got to use your all students take calculus right there. All right, so if I give you sine of arc cosine negative 2/3, when I see this, this is the angle whose cosine is that negative 2/3. But if it's arc cosine that's negative, I'm going to draw my triangle in quadrant 2. And then here's the angle right here. So the cosine is 2/3. That's the adjacent side over the hypotenuse side. You can put the negative if you want. When I label my triangle, I always use positive sides. And then when I do my final answer, my final trig function, I just use my all students hate calculus to determine what my signs are going to be. If you go 9 minus 4, use your Pythagorean theorem. You got that side. And now, since I want what the sine is going to be opposite over hypotenuse if you use your SOHCAHTOA. And since I'm in quadrant 2, that answer will be positive because sine is positive in quadrant 2. If I gave you the same kind of problem, or if I did tangent of arc cosine, squeeze in another example there, of the negative 2/3. Arc cosine negative 2/3 is using the same triangle, but now if I ask you what the tangent is, tangent you would do opposite over adjacent to get the radical 5/2. But remember, since you're in quadrant 2, use your all students take calculus, your tangent is negative in quadrant 2. So there you go. So that's a little pre-cal review for you. I know when I first started teaching, I thought that all my pre-cal students would remember all that. And then I was mistaken. And I was like, man, I need to build in some extra instruction with that pre-cal stuff. So that's fresh in your head because a lot of people forgot all that stuff there. So we want to kind of have these known throughout future chapters as well. We're going to do plenty of integrals in the future. And a lot of times we need to do a definite integral and plug in numbers. And we need to rely on what those exact values are going to be. Well, a lot of times we'll have arctangent of 1 minus arc cosine of negative 1/2. And we'll need to just make sure we know those values there, right? So that's the pre-cal review. And then the calculus review is you got all these properties over here. It might look kind of intimidating, but it's actually quite simple there. But if you have this means the derivative of arc sine of something is equal to that. The derivative of arctangent of something is equal to that. Now, what I have memorized in my head are these 3 here on the left-hand side. And then I know that if I do the derivative of arc cosine, it's the same exact thing as the arc sine, except it's going to be a negative. And so arctangent and arc cotangent are the same thing, except this one's going to be a negative. Arcsecant and arc cosecant are going to be the same thing, except these are going to be negative. So I have these 3 memorized. Now on your blue sheet review that I have linked for you, that's what I have. I have your 3 properties, and then I just say, hey, if it's an arc cosine, that means you stick a negative in front. If it's an arc cotangent, then you stick a negative in front, and that's what I'm just utilizing right here. So that's what I mean by that. And then another way to write that, and so instead of u, we could use parentheses. So instead of an arc sine of something, I could use a parentheses like we've been doing, right? And so what you do is you do the derivative of that thing, and then the square root, you get the square root of 1 minus that thing squared. So if I have arc sine of something, what I do the derivative of that t squared, which is a 2t on the top. And on the bottom, you simply do 1 minus that thing squared, which is going to be a t to the 4th, and then you're done. It is not difficult. You just have to know the property. That's it. It's a very simple thing. Now, obviously, if I put a t to the 4th in front of that, like t to the 4th times the arc sine of t squared, well, then you have a product at the beginning. Then you got to do the product rule, right? So you still have to recognize your products and the quotients, and we get all that practice that we learned derivatives before. But whenever you do the derivative of an arc function, that's what these properties are right here, which are on that blue sheet review as well. So if you have the arctangent of something, what we mean by this with the u's, if you have the arctangent of something, when you do the derivative of that, you do the derivative of that thing on the top. But on the bottom, you do 1 plus that thing squared. And then so when I do the derivative of that thing on the top, so I'm going to go 1/2 x to the negative 1/2. And on the bottom, we're going to go 1 plus this thing squared. No square roots, nothing. So when I square that, that's just going to become an x. And then you simplify that. I know I'm not allowed to leave the complex fractions there, but I could pull the 2 down in front, and I could pull the negative exponent down in front. So that just becomes this for my final answer there. So we really want to kind of practice that in this section, because in the next section, we do integrals with this. And so we'll see the integral of like 1 plus 25x squared, or the square root of 1 over the square root of like 1 minus 9x squared. And we have to recognize what those patterns are, kind of go in reverse to do the integrals there. So just make sure you practice the pre-cal, practice these, and just know those properties, and then just start really memorizing all these properties and patterns and stuff on your blue sheet review there. This would be really beneficial for you to make sure you know all that and save that.